We're going to take the complex number 60i minus 11 and then take its square root. Can you figure out the value? Pause the video to give this problem some thought, and when you're ready, join me for the solution. The first thing we'll do is set this expression equal to a generic complex number, a plus bi, where a is the real part and b is the imaginary part. Now let's square both sides. We'll just do a little rearranging of the right side. And it seems like this equation is impossible to solve. But there's a clever trick we can use. We can actually create two separate equations in terms of a and b by setting the real part on the left equal to the real parts on the right, and similarly, the imaginary part on the left equal to the imaginary part on the right. So now we have the following two equations. Let's solve the equation on the right for b. We'll get b equals 30 over a. And now we can substitute this expression in for b on the left. Squaring 30 over a gets us 900 over a squared. Now let's multiply both sides by a squared. Rearranging, we get a to the fourth plus 11a squared minus 900 equals 0. Since 900 is 36 times 25, this factors nicely as a squared plus 36 times a squared minus 25. Since a squared plus 36 will get us imaginary solutions for a, we can ignore those values. Remember, we're solving for a plus bi, and a is the real part. So we just have a equals plus or minus 5. Recall that we had b equals 30 over a, so b is 6 when a is 5, and b is negative 6 when a is negative 5. And now we can write our solution in a plus bi form. The two solutions to the square root of 60i minus 11 are 5 plus 6i and minus 5 minus 6i. Of course, you can square of those to confirm that you get back 60i minus 11. I'll leave that to you as a final check. Let me know in the comments if you got this correct and if you use the same approach or something entirely different. As always, thanks for watching and see you soon.